a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. By now, if your lessons have been going well, you should have this order of operation long since memorized. So let's use this review of order of operation for a more pointed review. Of these two operations, which must be done first? And if you know your order of operation, you will of course say the times. So on scratch paper, all we need to do is the multiplication between those two and temporarily neglect this. So on scratch paper, multiplying as though the decimal point wasn't there, we get our whole number product, count the total number of decimal places, that's 2, start on the right end, count 2. This end 0 is not necessary, so 8.4 is this product. Now, there is only one operation left, so there is no choice. So we write vertically, line up the decimal points, line up the decimal point of the answer, subtract, and we're done. The point being is between subtraction and multiplication, multiplication is done first. So this is really just several problems in one. But see what an opportunity it gives us to review our decimal arithmetic. Another problem. Of these two operations, which do we do first? And we hope that you remember that between multiplication and division, you do them as you come to them. So in this case, we do the division first. Had this been written first, we would have done it first. So we divide 6.3 by 9. Now relocating the decimal points and dividing, we get 7, which replaces the problem that we had done. Now, of course, there's only one operation, so we multiply as though the decimal point was not there, and we would get 105. We count one decimal place. We count one decimal place. My answer is 10.5. So between divisions and multiplications, you do them as you come to them. Whichever comes first, you do first. Now between this addition, subtraction, and exponents, which do you do first? And of course, exponents are done before anything else except whatever is in parentheses. So 1.2 squared means 1.2 times 1.2, which gives me 144 without the decimal point. But now don't make the mistake of saying there's only one decimal point. Actually there's 1, 2, because it says there are two numbers with one decimal place. So there's 1, 2 places, 1, 2 places. So this is the square of 1.2. Now, doing the next exponent, 1.3 squared, or 1.3 times 1.3, we get 1.69. Again, two decimal places. Now, for clarity, copying over the problem that I haven't done yet, we get this as our rewrite of the problem. Now between addition and subtraction, of course you do the additions first only because it came first. Between addition and subtraction, you do them as you come to them, left to right. So doing this addition between these two first, we get this as our sum, and we rewrite the rest of the problem. Now it's simply a matter of doing the only operation that's left. And we're done. Now again, remember, when you have a composite of operations to be done, don't look at the numbers first. Look always at the operations. And the grouping parentheses. Now, without doing anything, can we order which we're going to do first? And by the order of operation, we do what's in parentheses first. Then inside the parentheses, we do multiplications and divisions next. Then the additions and subtractions. And at that phase, the whole parentheses should be one number. And then we would do the multiplications here before we do the subtraction here. So if you really know your order of operation, it's simply a matter of identifying what you do first and realizing at any one time you're only doing one thing. So it's not that this is a hard problem, it's many problems in one, but each separate problem is quite simple. So doing the division first, we get and doing the next operation, we can just see visually that's 42.2. And now the parentheses has been whittled down to one number. So back to the beginning, we look for more multiplications and or divisions. So we now do that one. And we can see by inspection alone, this will be 422 because 1 times anything is itself. There's 1 decimal place, 1 decimal place, so 2 decimal places, and all that's left is this minus 25.8. And doing that, lining up decimal points, appending placeholder zeros if it will help, keeping the answer decimal point lined up, subtract, and we're done. So this entire beginning expression has evaluated to the single number 21.58. All of that was once again a review, a fast flying review I might add, of the order of operations. Ask yourself if this is memorized now. If it isn't, you should set aside some time and really memorize it. Now another kind of review. Let's say that Brenda filled her car's gas tank each Friday. During 1 month, her fill-ups were this. At the end of week 1, she filled up 12.8 gallons, 8.3 on the second week, and 15.7 and 10.4 gallons on the fourth week. Now, what was her average weekly consumption? But more important than that, what do we mean by average to begin with? Could you tell somebody in your own words without doing it how we're going to average these 4 numbers? And hopefully you will say you will simply add up the 4 numbers and then divide by 4. So our problem is simply an addition problem, then a division. So adding these, we would get Brenda's total for the week was 47.2 gallons. Now since there were 4 weeks, we will divide this sum by 4. Okay, the sum, the number of numbers, this is a whole number, decimal point goes straight up. Dividing, we get this, and since it divided evenly, we don't have to inquire about round off. So Brenda used an average of 11.8 gallons per week. Now let's see what this average can be used for. Using that average, what can she expect to use during the next 7 weeks? Now there's an underlying assumption here that she won't use the car in any unusual manner. That'll be more or less the same as her last usage. So rather than saying, well, we'll take 7 times this week, or 7 times this week, or 7 times this week, or 7 times this week. Now see, all of these numbers are different, so we have to ask what number is best to represent all of these weeks. And of course that number is the average. So we'll multiply the average by the number of weeks we're concerned, and we'll get a total of 82.6 gallons. Now this might not be correct. We're only estimating into the future, but experience has been found that by using that average, that will give you the best estimate. And that is one of the main reasons for using averages, to use a number from the past to give us a best estimate on a future situation. Now let's also use decimals to review once again in our getting ready for algebra exercise. If you have a simple equation where the variable is being operated on by multiplications and or division along with subtraction and or addition, recall that we undo subtraction and addition before we undo the multiplication or division. So in this case, to undo subtraction, we add to both sides, and of course adding undoes this, putting us down to just the multiplication now times the variable. And of course the number over here has become 9.8. Now all we need to do is undo multiplication. And recall that you undo multiplication by division, both sides. And now we have the variable isolated, which is what we mean by solving. And all we need to do is divide 9.8 by 1.5. And doing the division, we get an unending decimal, which is usually what happens. So if our answer is to be in decimals, we must ask, where do I round off? And you must ask that, or your situation must tell you. There is no math rule for that. And let's say the reply was round to the nearest hundredth. So here's the nearest hundredth. We look at the digit next to it. That's less than 5, so we round off. So this is my approximate value for m that will solve my equation. Again, the main point of review, however, was that in a simple equation like this, you undo the minuses or pluses before you undo the times or divisions. So in a problem like this, in our effort to isolate the r, which we call solving for r, we must undo that addition before that multiplication. And of course we undo addition by subtraction. And doing so on each side, we get this, undoing that, and doing this subtraction, we get 13.6. Now to undo this multiplication here, we will divide, in this case by 2.4, both sides, and this undoes that, leaving the r isolated. And carrying out this division, we get, and again we get an unending decimal, so we must ask of the physical application or whoever is having us do this, how do they want us to round off? So in this case, let's say our instructions were to the nearest tenth. So there's the nearest tenth. We look at the digit just to its right. That's 5 or more, so we add 1 to the round off place. So my answer is approximately 5.7 as the value of r. So this lesson has been quite a review lesson, a very good one. When you need to solve an equation, and remember that solving equation means we're trying to isolate the variable, we're trying to, in effect, peel these other numbers away. And we stated on the last two problems that if you have divisions or multiplications on the variable, as well as additions and subtractions, you undo the additions and subtractions first. However, it might be a convenient way to look at it as though you had the m already and ask yourself, by the order of operations, which would you do first? The multiplication or the addition or the division? So in this case, of course, we would do the division first if we knew m, and then we'd take the results and add them to this. If you would begin to undo things, you want to undo things in reverse order of the order of operations. So if I were evaluating this, I would do this first and then this. So since this is the last thing I would do by the order of operations, when solving equation, it's the first thing I will undo. So you undo operations in solving equations in reverse order of operations. So in this particular case, we would undo this addition of 5.9 to this first. We do that by subtracting, and of course I must subtract the same thing from both sides. And this subtraction of 5.9 undoes this addition of 5.9, isolating now not the variable, but the variable and its division process. And of course, over here following through with this, we would get 4, 2. Now, of course, there's only one operation to undo, and you undo dividing by multiplying, and of course by 1.3 here. Then I must multiply the other side by exactly the same amount. So the multiplication undid the division. So I finally isolated my variable. Then you do the multiplication either by hand or by calculator. And again, we recommend at this stage of your math review that you do this first by hand, and then if you do have a calculator, redo it by calculator to check your work. So actually the way we would ask that you do this is that you actually do the multiplication. And remember, by multiplication, I didn't really have to write these decimal points down because I multiply as though there were no decimal point. Then I count the number of decimal places, starting at the right end, give it to my product, and we're claiming by hand my answer is 3.12. Then double check it on the calculator. 2.4 times 1.3 equals 3.12, and we know that we're correct. You might notice that I have a slightly different calculator here than the one I've been using all along. This has been a scientific calculator, and this one is what we call a simple four-function calculator. See, it has division, multiplication, subtraction, addition, the principal four functions. It also has memory and a square root key, so really it has 5 functions. But it's important, if you're using calculators, to realize that when you're doing many operations simultaneously on a calculator, not all calculators work the same. So let's play with these two with a few order of operation problems and give you a feel for how the scientific calculator and how less expensive but very good inexpensive calculators work different from each other. You should realize when you purchase a calculator that not all calculators work exactly the same. Not only are different brands different in operations, but different models within the same brand will frequently operate differently. So the first thing you want to realize is don't throw away your instructions manual. Keep that for as long as you have the calculator. Also, when you're going to experiment with doing something new on the calculator, before you work a problem that's important to you, be sure that you make up a problem that is so simple you can work the answer without the calculator easily. Then do it on the calculator the way you think it should be done and see if you get the same results. Let me give you an example. Let's consider this very simple order of operations problem. We know from similar lessons to this one that you must do the multiplications before the additions. So 3 times 5 is 15, added to 2, and of course the answer is 17. Now on a calculator, if you were to do that problem, you have a choice. You could just do the order of operations as you know it. So I could say 3 times 5, 3 times 5, then add the 2 to it. And of course you get 17. So you're always safe if you do the operations and key them in the order it should be done, not in the order that is written. However, on many of your scientific calculators, probably all of them, notice what happens here if I key in the problem as it's written as opposed to the way it should be done. So if I hit 2 plus 3 times 5, now if I were to work it that way, 2 plus 3 is 5, times 5 is 25, the wrong answer. But look what happens here. I get the correct answer. But if I were to do the same thing over here, 2 plus 3 times 5 equals, I get the wrong answer. What happened? Well, on scientific calculators, the order of operation is built right into the circuitry. So in effect, your calculator doesn't finish your arithmetic for you until when you're all done keying the numbers in and their operations, you push the equal sign in. So as you're keying in the problem, the calculator is remembering it, not doing it. And it does it when you push the equal sign. And it does it by the order of operation, which is part of the calculator. It's actually built into its circuit design. So when you buy a calculator, you need to check, does it do the order of operations for you, as this one does, or must you do the order of operation, because the less expensive calculators will do operations only 2 by 2 as you key it in. So if I keyed in a 2 plus 3 is going to do that first, which of course is 5. Then take that answer, which is 5, times this 5, and I should get 25, which I do. So if you have a calculator, the first thing you want to ask is, does the calculator do order of operations? If it does, you can key in the problem exactly as is written on the paper and not worry about the order of operations. The calculator is going to do that for you. Push the equal, it pulls out all the numbers you've keyed in and their operations and does it in the right order. On the other hand, if your calculator does not do that, as this one doesn't, then you must put your problem into it in the order that it must be done logically. So you would have to say 3 times 5, and that answer added to 2 equals 17. So if you have a calculator with you now, you might want to take this very simple problem and check it. If I put it in this order, do I get 17? If I don't, then you know that your calculator does not do the order of operation. If you do, then you know your calculator does. So you might want to take a few moments right now and check your calculator out. If it does then doing a problem like this is fairly simple. You can forget the order of operation because your calculator knows it already. You simply key the problem in as it's written. So I would key in 4 plus 18 divide by 2 minus 2 times 5. And now don't worry about what's been appearing here because the calculator has not been doing everything until I punch this equal. And as soon as I do, it tells me that the results should be 3. But if, on the other hand, you have a calculator that does not do the order of operation, then it means that you must mentally do the logic. And the calculator will merely do your arithmetic 2 by 2. So I know that of this plus, division, minus, and times, logically I must do this division first, which is 18 divided by 2 equals, and that's 9. And I want to store that either on paper or in memory, because I don't want to do anything to the 9 yet. I want it just to sit while I clear the calculator and do the next order of operations, which is 2 times 5. Then I want that to just sit while I clear my calculator and go back and do my next one, which is 4 plus 9, which is 13. Now I know I want to add that, subtract from that 13, 10, so I can just push minus 10 equals, and I get 3. Now, of course, this problem is so easy, I hope nobody would ever use a calculator to do it. It should be done by hand. In fact, it should be done mentally, shouldn't it? However, if you have a problem like this with only 2 operations, it still, nevertheless, is more convenient to do it on the calculator. And if I had the scientific operation calculator, I could key that in and hit the equal. If I had a non-order of operation calculator, then I must make the decision to do this one first. 18.64 times 2.03 equals, then take that answer and add to it this answer, 48.56 equal, and I'm done, and then round it off right on my calculator. So please note, this matter of calculators is not a simple matter. Calculators do operate differently, and many calculators do not allow you to forget the order of operation for the simple reason the calculator doesn't know it. So you must tell it what to do, when to do it, and what to do it to. Hence, you must know the math. The calculator just carries out your directions. That's all. Well, that not only finishes this lesson, but we have completed another chapter of study. So in the next lesson, we start a brand new topic, which will use decimals, fractions, and whole numbers. Until then, this is your host, Bob Fennell. Good luck.